Hello, everyone. Welcome to our first webinar of 2021. Been looking forward to this. We all had a little bit of a break. I didn't know what to do with myself on webinar days, but here we are with another one. We've got a great schedule coming up. We'll share the next webinar here in a little bit, and since we're going to be doing one a week every Tuesday. And hopefully this crazy motorsports world we have with the scheduling that happened to us with the stuff that was happening last year. It was hard to schedule people. We were scheduling people for just fine, but getting everybody to come in and schedules changing because of the way things were happening made it hard to let everybody know ahead of time what webinars we had coming. So we typically held them until the one before, just to give everybody freedom to do the regular jobs if they needed to. So, but with this one, we're hoping that we can lay out and get our co-hosts and guests scheduled early enough and let everybody know. So hopefully we'll be doing that. This one here, this is one that's going to be interesting, and it's something that a lot of people have a strong interest in, and our co-host Ray Phillips, who we'll introduce in just a moment. Ray mentioned this to me, gosh, a month or two ago, saying that this would be an excellent topic, and I agreed. And it's something that I've done a few times in my career as well, looking at things like this. So it was interesting what we're going to look at, but it's also interesting is because of some of the detail you need to get into to look at accident data analysis. It's also going to be very, very helpful for the techniques that Ray is going to talk about and show, is going to be very, very helpful to everybody in your normal data analysis tasks. If you want to really look at how close you are getting on the throttle, getting on the brake on corners or whatever, getting everything aligned just perfectly. There's all sorts of little tips and tricks he's going to give us here today, which will be pretty cool. So it will be a good time. So again, thanks everybody for coming. What you're going to have is we're going to go ahead and share the user profiles that you're going to see, and the math channels. There's a couple special math channels that Ray is going to introduce and talk about, and we'll have those into the link in the chat box, and we'll also have those in the recorded version of this. If you're watching this on YouTube, they'll be down in the description box down in the YouTube video. So with that, let's go ahead and get started and introduce Ray. Ray owns Precision Driving Analytics, and it's a company that's been around for quite some time. And what I like about Ray joining us, it's his fourth time joining us. What I really like about Ray is he's very, very good with his data and the analysis and that side, but he was also a driver, and that adds an element to data analysis. I think that is above some of the rest. That when you got that feeling, that feeling of what the car feels like, it helps you in data. And it also, and I think a good data guy can be, maybe it helps them be a good driver as well. Well, you need to understand the car from many different standpoints, and of course understand the data. Data engineer in the Ferrari Challenge championship team in 2019. I took the a little bit pretentious maybe, but I added in one of the bullet points of all this great accomplishment he has that he gave me for his 3 data points, I added 4-time AIM Sport webinar co-host, which that puts it right up there with all the rest of the stuff that he's done. It's probably not quite the accomplishment of some of the other stuff he's done. But I appreciate you being here, Ray. Give us a little bit of a background on some of the stuff that you do, and what's going on with you in 2021 as if you have something lined up already, and some of the stuff that you do that I know some of our attendees have used in the past. You do a lot of work on user profiles and accident data analysis as a service. So give us a little bit more background on you, and then some of the stuff that you can help the folks with.
Yeah, okay. Well, first, thanks for having me, Roger. Happy New Year, everyone. Hopefully 2021 is better than 2020 for most people. As far as me, I don't know, racing has just been in my blood for about as long as I can remember. I started actually from the bottom up, I'll say. I started crewing for somebody in 1994. Guy raced a Formula V, and I ended up racing Formula Vs for 14 years. I started racing myself in 1997. Then I built my own car and raced a Formula F, and had a lot of fun with that. Put a full-blown data system on that car, even created my own shock sensors, and just really learned a lot about data. I also hired one of the best data engineers, in my opinion, John Block, during that time period, and learned so much from him. It's crazy, and really got into um, just starting to help other people. Just realize that if I looked at somebody else's data, then I could find things that could help them go faster. And decided that, I decided to get out of racing. It was costing me a little bit too much money, but really enjoyed the sim racing and doing the data analysis. So I just ended up starting my company where I did that. And I use data a lot in simulators. I'll work with people on simulators. Um, and a lot of the stuff I'll try on simulators, knowing that we're going to be experiencing some of that in real life, and see what the data looks like if you do that. So, there's just so much you can do with data now. And I just really love that. I don't think you can race at a top level without using data these days. So me being as analytical as I am, I just really love trying to help others go faster. I love digging into it.
Yeah, but your background in the driving and the analytical mind put you right in the middle of this data game, right? So very, very cool. The couple things you said there before we actually jump over to the actual presentation. Your first race, 1997, you mentioned. My last race was in September of 1996 is when the last race I drove in. So it's kind of interesting there. And you mentioned John Block being a friend of yours and somebody that you have a deep respect for. John has been I'm not sure if he's here right now or not, but John has been a co-host with us a couple of times, and John's going to have I think maybe 2 or 3 webinars down the road in the next 3 weeks or so. John's going to come back and do another one that's been highly asked for. People have been more than 2 or 3 people have mentioned to me that John does some things in some of his training around braking, and John's going to come in and give us an entire hour of some of the tools he uses and some of the thought process he uses on optimizing your braking. So that'll be pretty fun. So that's an upcoming webinar. So appreciate that. The interesting on our next slide, it's not a bunch of slides today. We are going to go in and what we're going to do, since it's accident data analysis, we're just going to bring up data and video and just go right at it. So this will be the end of the presentation until we get to the end of the show here for the last hour or so, and we're going to jump right in. So I'm going to open up. I'll bring up the data, but we're going to play the video first because you're going to see some things, and we just want you to see what the accident maybe looked like on video. And Ray's going to give you some ideas of how do we figure out what happened. We got the video to look at, we've got the data to look at, and so it'll be kind of interesting. Ray, you want to start with we've got 2 videos, and Ray, you want to start with the normal one, right, where we actually make it, the car makes it through there and get going. Why don't you kind of set this up, and I'll be ready to fire up the video when you're ready.
Yeah. So what we're going to be looking at is it's a Porsche car. I don't remember which model, but we're at Watkins Glen, and this is going through the bus stop. And if you've ever raced Watkins Glen, the bus stop is really fast, and you tend to use quite a bit of curb if you're not in an open wheel car. So it's kind of tricky. You have to get your entry just right, because that kind of dictates how you're going to end up coming out of it. And frankly, there's been a lot of accidents at this spot, because if you get it wrong, you're coming right towards the guardrail. And there's not much runoff room when you're in that situation. But you know what? Accidents happen. Anytime you get on a track with your car, there's a risk of being out there. And frankly, if you don't realize that, you shouldn't be out there. And sometimes you gotta have to find that edge to know, what you can't cross over. I think you can do it so that you're not crashing, but the fact of the matter is sometimes things happen that's out of your control, and it's an accident, and it's something you can learn from, and that's really the point of all this, right? Is to try to learn from what happened and maybe do something differently the next time to prevent it from happening.
Yeah, it's like almost everything else in data when pre-data, or if you don't study your data, you know something happened, you know what that end result was, you lost a second in qualifying or whatever happened, but you don't know why. So if you have an accident in a certain corner, that you're going to lose a ton of speed there for a long time until you work your way through figuring it out. Boy, having the data and the video and the knowledge of how to do this will help you understand what happened, and then you can get back at it and learn from it and be much faster. So, okay, you want me to open up the first video?
Yeah, go for it. So this is the car going through the bus stop. The driver. It's actually the previous lap to the crash lap. And it's a little choppy, but you get a good idea of the line that he's taking and how much curb he took and how much curb he took coming out.
You want to play that one more time to see it, or you think you got what you needed?
Yeah.
Okay.
Let's play it one more time.
Okay.
And pay attention to where the car is on the left side of the road.
What he's talking about is, and I'm going to pause it occasionally, and we can take a look. But this is the same lap we just watched all the way through, and you can see he's over towards the left edge. There might be a foot or two there, right between the edge of the tire or something, but he's pretty well left, right?
Yeah.
And then I'll just kind of play it for a second, and if maybe we'll pause it at the apexes.
Yeah.
You can see he's taking a lot of curb, right?
Yeah.
And if I go one slide at a time, he might even be touching a little grass right there, right? Yeah. So
maybe
a lot of curb. Let's go to the next one. It did kind of pause there, but now we're on the second to the left-hand curb. He's using probably half of that. If I went a couple of slides, he's up on the rumble strips a little bit, right?
Yeah.
And then
it's a pretty tight line through there.
Yeah. And he's using a lot of that curb right there.
Yeah.
Right.
It's hard to see, but he actually ends up having a little bit of a moment just after this curb. Now, it would be better to have a camera that was seeing his hands, but
that one throws it the rest of the way.
I think the driver had that camera, but unfortunately the card was out of it or something. So this is the only video we had to look at.
Okay, so then we'll go to the crash data. And again, do you want me to play it all the way through and then come back and dissect it? Okay.
Yeah.
Let's play that one. It's literally the next lap.
The sound, I will say the sound and all is not exactly lined up with the video itself.
Okay.
By listening to that, it sounded like he accelerated all the way to the wall, and that's not what happened. So
coming through Zoom, it actually sounds here locally where I'm playing it actually is okay. So okay, let's bring that back up.
All right, so let's step through the entry, Roger, if you can.
Okay, there I've paused it still quite a ways back, just so everybody can see it.
If you can step through, we can look to see how he's entering the bus stop here.
I'm just taking it frame by frame.
All right, you can see that he's starting to kind of pull away, kind of creep away from the left-hand corner at this point. So right off the bat, we know that his trajectory is a little bit different than the lap before.
Mm-hmm. Okay, and then let's take it down. You can see he's really starting to arc it into the corner already, pointing down. I'll just go frame by frame. I assume you're seeing this fairly well.
Yes.
Okay, and there he's probably just a little bit less curved than what he was in the regular lap, right? In the good lap.
Couple feet more to the left, I'd say.
Okay. Okay. Let's take it up. Let's see if it'll go. Every once in a while, when you do this frame by frame thing, I'm going kind of slow so everybody can see it. Okay, he's starting to transition to the bus stop to the left-hand side, and I'll pause it here. Let's get right here where we can see as far as he gets over. Right about there, you can kind of see it. What do you see there, Ray?
Well, he's a little bit further to the right. It's pretty hard to tell in this video. We're going to see that a lot better in the data. But we know that his heading is a little bit different, just by the way that he came into it. And the one thing we didn't look at was his speed is actually higher as well.
we'll see that
So
in the data as well.
yeah, we'll see that in the data as well. So I would
Okay,
just continue.
let's see if I can get this to play. Let's try it again. One through. Now it's starting to rotate, right?
Yeah. So, again, it's kind of hard to pull out of the video, but there actually was a little bit more rotation in the middle of the corner. But in watching this, it's really easy to come to the conclusion that, oh, he took too much curb coming out of the bus stop, and that's what caused it, because he did take quite a bit of curb coming out. But, that's not necessarily why this happened, and that's what I'm going to show you.
Okay. So you want to jump up over to the
Let's dive into
data. And then what we're going to do is, like we typically do, is somebody Peter says, look at all the skid marks there. That is true. That's one thing I noticed as well, Peter. There was he's not the first one to hit those tires, right? Even on that weekend, I don't think. Let's remote. Yeah, exactly. Ray. Okay, Ray, make sure you click once in the data, and then you should be running it. What we've got here is Ray Studio 2. We're gonna do everything we're gonna do today in Ray Studio 2 analysis. And again, Ray has got some math challenges he's going to use here and some user profiles. Robbie will probably put the link in the chat box for those watching it live, and they'll be in the description box in YouTube. Give us an understanding of what we're looking at here, Ray, and then we'll go ahead and get started.
All right, so we kind of cheated in advance here, but right now the reference lap is the crash lap, which is only 50.67 or 66 seconds long. If you pull this up and you disable that lap, then you're going to have problems, because really that needs to be the reference lap. Well, I'm going to show you something here. I'm going to go to map and map manager, and I'm going to scroll down here. So what I did is I created a map just for this crash lap. And what I did is, if I click on, modify select, I don't know if it'll show up there. But bottom line is, since it's open, not a closed map, I chose open. So just like you would do with a hill climb, that type of thing. And that allowed me to basically make this lap as my reference lap. And that's important because that's what we're comparing against. And, I think normally Watkins Glen is 17 some thousand feet. Well, now we're only looking at, 7,200 feet or whatever that is. So, the first thing is create that map so that you're comparing to this crash lap. So now we want to look at the lap before. So I'm going to check that, and you'll see, nothing's lining up here, right? Because now that normal lap is being compressed into that 7,200 feet that we defined with the crash lap. So I'm going to do the snap function. Now I'm going to look at my colors to make sure. So my crash lap is yellow and my normal lap is blue. And if I click over here in the GPS, my crosshairs, where I have my line here, this is the crash lap, and I'll use the control feature that Roger showed me. And this is your normal lap. So what we have to do is we have to get these two crosshairs on top of each other, because that's using GPS to determine the exact point, that we're going to be looking at in the data.
And the reason that he mentioned it a minute, but the AIM Ray Studio software it is created to match lap on top of lap. That's the normal use, right? And we're expecting that you're going to be 5, 10, 15 feet of rollout distance different on each different lap. All that's fine. You're never going to be exactly the same. So what behind the scenes, the software is doing some stretching and pulling and making sure that of course we know where you start, but we want you to end. We want the lines to be at the same spot. So the software does that. And what you're seeing here is over the course of these two laps, one being 17,000 feet and one being 7,000 feet, that it's trying to stretch it would have tried to stretch the short one, but since Ray applied that map, it's trying to shrink down the long one. This is when you have an off, or the engine blew and you pulled off to the side of the track, and you really want to get back and see how that first part of that lap went, or maybe a yellow flag came out and you had that first half of the lap that was super good. These are little tricks that you'll use in many different ways, not just accident investigation, to get it where you can align these laps and look at the time compare bar, or look at where you were in certain corners. So Ray, is some of these tips are not just for accident
No,
reconstruction
not at
things.
all.
So
Yeah.
okay, perfect.
All right. So I don't know how to explain this exactly, but what I want to do is I want to move the normal lap to a point in the crash lap so that they overlay. Okay. So blue is my normal lap, and I'm going to move that to the line, or these measurements down here at the bottom, and I'm going to move those to the right. And what you're going to see over here is you're going to see this crosshair come backwards all the way to the crosshair that's here on the back straight.
And while he's doing that, once you turn that snap mode on, you had the 2 bars down below, which then allows you to individually move each lap. So he's just going to drag that around until it aligns. Here it comes. You see it coming down into the toe of the boot right there. It's going and going and going. And you'll also notice, right, you got pretty close there. They're in the speed trace up above. You can see they start to align on top of it all, right?
Yeah. All right. So if I click here or here, now if I zoom in on the GPS,
drag that over.
You'll pretty much see that the crosshairs are now aligned. So now,
yep, he's done such a good job. We're actually seeing them right on top of each other.
and what do you know? If you look down here at the the feet, those are lining up as well. That doesn't always happen,
right? Yep.
but it's happening here, which is great. So now we can focus in on the bus stop, which is basically starting at this point here where I'm a cursor. So I'm going to zoom in to that. All right. So now, there's a few things that stand out already. We've got speed, we've got steering, we've got throttle, and we got brake. Okay, and there's a time compare at the bottom. But right off the bat, you can see that he's carrying a lot more speed in on the crash lap. And in fact, at this point, he's about 10 miles an hour faster.
Yeah.
At the apex, he's about 4 miles an hour faster. So that's a pretty good chunk of time, or chunk of speed there. Can't see a whole lot with the steering trace, just cursory looking at it. But if you want to see how much later he got off the throttle, we can use our little triangle measurement tool and click. Well, I didn't really click that one very well. I'll try to offset it. That's about 60 feet, probably a little bit less, but still that's a lot. If you're building up to something, that's a big chunk to take off in one lap. Now he's driven this track a lot, so I'm sure he knew that that's about where he would normally be braking. But still, that's a pretty big difference between 2 laps. So that's one item of note, I'll say. And you can see the braking is probably a little bit less than that, but not much. So this is basically the start of the analysis. Now, we now see that he broke later, he carried more speed in. Okay. So where can we go next?
Before you go on next, let me. There's a couple of quotes, a couple of questions in the chat that I think are worth chatting about real quickly. First one is maybe some people can't see the blue very well. Chris, who's been here, I'm going to take over the mouse for just a quick second, Ray.
Sure.
I'm going to change that. I'm going to change that blue maybe to a bright red. Let's see if that jumps out for everybody a little bit more. I know, Ray, you tend to like to use the red and the yellow a little bit as well. Yeah. So I will, and let me bring that back where it was. So hopefully you can see that better, Chris, and anybody else, let me know. The second one was kind of interesting, and you touched on it already, but I wanted to just make it even clearer. Todd mentions but couldn't that be because he's still out of phase? And that is really what he did. What Ray did first, Todd, was with aligning these X's. I'm going to zoom in just a little bit more, and yeah, it's a little bit out of phase, but not very much. So if you zoom way in here, and then you grab now the red one, and if you once you get those guys, and sometimes you have to, this is where it's touchy depending on your mouse, but if you get those side by side or extremely close, once you get these aligned perpendicular to each other, now the out of phase is not out of phase. It's truly him going in and getting off the throttle earlier on the one lap and later on the other one. So Todd, I just wanted to make sure we kind of cover that boy, that's what this aligning of these X's are all about. And you're going to see Ray do that several times as we go through this process, because when we come down here farther, he may have driven, we seen it in the video, he drove at a different line, so he went more feet or less feet in actual driven distance. So aligning these two together is the key to that. It's easier to do the more zoomed in you are to get it exact. So okay, so now when we look at this, and I'll just do it real quickly again. It's really hard for Ray to do this from the other end through Zoom, clicking at very, very fine points, right? So
Yeah.
there's your 62.2 feet with it aligned pretty darn tightly. So, okay, let me jump back out here. And
Yep.
there you go, Ray. You'll need to click once and then you're off and running.
All right. All right. So let's actually talk about the GPS a little bit. So we saw that in the video that his lines were a little bit off. If I really zoom in and move this around, you can see that indeed on the yellow lap, on his good lap, on his crash lap, he is further inside, and you can see how his heading is different here. He's going more straight at this point, and on his good lap, he had more steering input to get the car more over to the right. And this, affects him all the way through, because now he's in the middle of the bus stop and he's further out to the right as well. He's going, the direction is down. So yeah, this is great to use as far as looking at the lines. And if I've heard a lot of people say, well, GPS is inaccurate. Well, Roger's going to talk about this a little bit, but if we scroll down here to the position accuracy, it's at that point, it's at 0.96 meters. But as Roger will describe, it's actually closer than that.
Yeah, the GPS is positional numbers in GPSs can be a little confusing.
Yeah.
We give you, all of your AIM devices are going to give you a GPS positional accuracy number right there that Ray is pointing at, and that number is for that tenth of a second. In this particular case, it's a GPS 08 receiver. In that tenth of a second, across the entire world, we're telling you that we're going to be 0.96, I think, if I remember right, what it was, 0.96 of a meter. It's a meter. You're going to be inside that circle 85% of the time, and that is independent of that second lap or any other time or day. It's telling you how close all the values all add up to give us a statement of positional accuracy. Now, don't then look at that and say, well, I'm almost a meter, that might be right or wrong. Because of these are back-to-back laps, there are errors that are making up this 0.96, whether it be weather or any number of things, position of the satellites in the sky. But because this is only happening about 2 minutes later, a lot of those errors are kind of they're on both sides of the equation, so we can take those away, and you end up with your actual relative position between these two laps is much closer. So if I looked at that number 0.96 and I seen a 2.0 or something, right, then I begin to get a little nervous on doing some of what Ray is showing here. But 0.96, that's that's pretty decent. You're going to see a lot of 0.7s and 8s, around the 1.0 numbers, and but don't get too hung up on that being, boy, it's 3 feet off all the time, right, or 1 meter. It's the relative accuracy between the two is actually much closer than that. So it's a good thing to kind of have a quick chat about, but don't worry too much about it.
Yeah, I mean, I've actually seen, in the old devices, 3 meters or something
Exactly.
like that. you know, so.
And the video is showing, remember when we watched the video, is showing the same thing that this driven line map in the GPS is showing us. The driver was crowding in and starting to cut in a little bit too early on the yellow lap, on the accident lap, just like the GPS position data is showing.
All right. So I'm going to bring up another user profile now. And this one I've called corner radius. And what corner radius is, I guess we should change the color back to red.
Yeah, just take that blue one and take it to any of the reds, should be fine.
So this is actually a pretty simple math channel. I'll bring up the math channel so you can see it. So corner radius is simply speed divided by lateral acceleration. Now you're squaring the speed and you're converting to feet per second on both, okay? So if you square, all right, so you've converted speed miles an hour to feet per second and you've squared that. So now you have feet squared and seconds squared. And this G2 FPS is actually converting G's to feet per second squared, okay? So when you divide those two, you're left with feet. So that is the radius in feet of that driven path, you know? And I've tested this. I've looked at maps that have the radius of the corners identified and compared to what is being calculated here. And it's amazing how close they are, especially if you're driving, you know, a normal apex, okay? Because basically where this is at its peak is the radius of that corner, okay? All right, so now that we know this radius, I'm gonna, or being able to compare these two. So this being up, that is the right-hand corner basically going into the bus stop. And this is when the car starts turning left, okay? You can also do these at absolute values, but the good thing about this is that we're seeing right hand and left hand, okay? So I can see right away that there's a difference here. This is the travel path of the car, all right? And on his good lap, you can see that he's basically coming out of that right-hand turn sooner than he is on the crash lap, okay? So if I zoom in on this, and I got to make sure my crosshairs are still lined up, which looks like they are, but I'll come over here and make sure.
Now that you're zoomed in, it makes it really pretty easy to align those things once you zoom in even more. It looks pretty darn good.
Looks pretty good, yeah. All right, so these straight lines down are telling me, you know, this is when the car transitioned from being in a right-hand corner to a left-hand corner. So let's see what that distance is. Again, I'm going to use the little triangle measuring tool. And that's showing me about 22 feet, maybe a little bit less. I can move this over a little bit. That's too hard for my end. So that's a pretty good distance different. You know, when you're doing 80 some miles an hour, and now you're asking the car to turn more sharply, effectively, by 22 feet, you know, that's another item that we need to be aware of. Okay. And you know, the more I use this corner radius math channel, the more I like it, because I can pick out things like that. And it really does tell you the path that the car is heading at, you know.
Yeah, it's always interesting because we always want to look at steering, or we want to look at throttle, or and all of those things are components. This is the final result of what the driver has turned the wheel and has done, you know, pointed the car down early into the corner on the faster lap. This is showing what the rate of change of how quickly the driver is, you know, bending it around that corner and where the transition was. So this is the final result of a lot of the stuff the driver did. So that gives it some even more interest.
Right. And you can kind of see this in the steering, right? If you look really hard, you can see that the red line coming into the corner, he actually started a little bit early. He started turning in early on the crash lap. and then there's a little bit of separation here, and then there's more separation here, but it's just not emphasized when you're just looking at it at the steering trace. And that's a lot of what I'm showing today, is how to emphasize some of these things that you may not see if you're just looking at a data trace or steering, or for anything else really. The other item of note is, if you look over here, this is where they really part ways, right? You know, here is showing that the car is coming out of the corner, and here he's going straight, right? So at this point, you know, he's not coming out of the corner until he hits the wall, basically, right?
Yeah, not good.
The other item of note is that he got the full throttle a little bit later, and he stayed at full throttle longer, but then he started coming off, and it kept coming off. So he knew at this point in here somewhere, he knew something was wrong. Okay. So that's, again, we're just kind of, you know, adding everything up. And so that's one thing I like to look at. Now
Yeah, what Ray's doing and I'll just chat, is he's going through some of getting the next user profile. Ray is just walking down the list of things you might want to look at. We first looked at video, then he looked at throttle off and brake pressures, and then he's, you know, this one was steering and the bending the car around the corner. He's just walking down these paths trying to figure out what happened and why, you know, why this happened. So now he's going to go kind of to the next level.
Yeah. So another thing I like to look at is yaw. Okay, so I'll try to get my phone out here. So if you don't know, if you have a pencil or something through the roof of your car, going all the way through, yaw is the rotation around that pencil. So as you go through a corner, the car yaws. If the back end steps out, the car yaws. Okay, so yaw is a very important thing to look at, you know, because it can help you understand really what the car is doing. And I'll show you my math channel for yaw. And again, this is another simple math channel. So yaw is simply lateral G's divided by speed, okay? But again, we're converting to feet per second. And when we do that, we actually come up with radians. And I want to get it to degrees so that I can compare it to steering. So AIM has another conversion factor here in degrees to radians. So if I was going the other direction, I would multiply by it, but in this case, I'm dividing by it. So now I'm going to have the number of degrees of yaw that the car has, and I change my scale so that it matches the steering scale. So 150 and minus 150. And again, this is steering at the steering wheel, not at the tires. So if, did I do, oh, yeah, I'm good. If yaw is similar to steering, then if the car has neutral steer, then it would make sense that the yaw would be on top of the steering trace, okay? And that's what we're seeing here. So if there's no wheel slip, then yaw and steering should track all the time, right? So if there is more steering than yaw, then that would kind of indicate understeer, right? If there's more yaw than steering, that would indicate oversteer. And that's what we're seeing down here. I actually calculated a steering to yaw ratio, and I did filter that a little bit, because if they're right on top of each other, steering and yaw, then you can end up getting pretty large numbers because you're dividing by very small numbers sometimes. So what I figured out is that if I take the absolute value of yaw and determine if it's greater than 0.5, then give me that steering ratio, steering to yaw ratio, which is steering position divided by yaw. Otherwise, give me 0. And that just makes it look a lot better. And that 0.5 is an arbitrary number. And I came up with that by looking at the data and figuring out the window that I should be in. So this is the whole crash lap. And you can see as the driver comes into turn 1, he's got a little bit of understeer. You see more steering, and you can see that, because he's got more steering, that steering to yaw ratio is a little bit higher. Looks like he had a little bit of moment here going through the S's, because now we're seeing the yaw is greater than the steering. But let's come back to where we really want to focus in on.
As you're zooming in towards that area, there's just a couple of questions that will slip in here real quickly.
Okay.
David, the sensor being used for yaw and how is it calculated? He quickly went over that, but it's in the math channels that you can take a look at, and that ties into Matt's question. Is do you ever use the gyro or the included yaw rate instead of the math channel? Some data loggers have a yaw sensor built into them, or the gyro is pretty close to that same value. Why in this case are you selecting to do this as a mathematical from GPS values?
Well, I just have more luck with this. A lot of times the other sensors, especially a yaw sensor, can get a lot of noise, and it's just easier for me to do it this way sometimes. I do use the gyro sometimes. In fact, you can compare gyro to the calculated yaw and also get an idea of understeer and oversteer. So in this case, I just thought this was the best way to go, to be honest. So.
And for somebody like you that is looking at a bunch of people's different data, if somebody has an MXL or original solo DL, the yaw sensor is not in there. So your math channels, everything you're building here works for everybody. And somebody that has a new solo or a new current AIM product, we do have those that the yaw sensor built into that, and people should. I would, if I was looking at it, I'd use this yaw one, call it a GPS yaw, and use a sensor based yaw and throw them up there and see which one works best for you.
Right.
So.
Okay. Yeah, I mean, a lot of the things I decide is because I played around with it, and
Exactly.
and something makes more sense to me, or whatever.
It was a good question. I'm glad we were able to chat about it a little bit.
Yeah. So so really, what we're looking for is when the steering trace and the yaw trace part ways. Okay. Well, what do you know? That's exactly what's happening at this point, 6,700 mark. They start to part ways. And what do you know? The steering to yaw ratio starts to decrease until it gets negative, which tells me the car is now in oversteer condition. Okay. I happen to change the color channel on for the GPS map. And if you don't remember how to do that, if you go to modify and then color channel, then you can choose whatever channel you want. And you can play around with the colors by going over to the measures and then using this bar to change it. So, I've kind of reduced the scale, so to speak, but right here, we're in full yaw mode, and now that's in the green. If I come back and say, okay, well, I start seeing a little bit of color change there. Well, what do you know? That's right when the lines start to separate. Okay. So visually, this is a good way to look at it as well.
Different learning styles, right? Our friend James Colburn has had one discussion on learning styles, graphical versus the lines versus text. We hope to have him back here fairly shortly and to do another part in that.
Yeah, while I'm here, there's another GPS channel that can be helpful sometimes, and that's GPS heading. So if I, where'd that go? I was trying to pull it up.
Yeah, try it again. Want me to?
Yeah, no, I got it.
There you go.
Huh, just not showing though.
Well, that is interesting. Click in the measures graph and then bring it, and then click over there and then maybe try it one more time.
Maybe that's why.
Yeah, that is there it is. That's odd. That's odd.
All right. So I'm going to try to bring in the other lap here, and they're probably not aligned, are they? Well, I may have to give up on this, but this may take me too long. But bottom line is, I looked at this, and at that same point, the GPS heading was starting to diverge as well. So that's another channel that you can end up looking at. And almost every dash now has GPS. So, you can get a lot out of these GPS
Exactly.
channels.
Exactly.
So we still haven't really answered why this happened, but we have a very good idea of where it happened, when it all started. So I'm gonna pull up something else, and this is the yaw, and I've added something called wheel slip, and I've added the RPMs at the bottom, and and I'm going to describe what wheel slip is. This is here, and what do you know? At this same point, we're looking at the left rear wheel slip, and when it starts to spike like that, that means that there is wheel slip. Okay, so in this case, it's a rear tire, and it started spinning up. Okay, now I'm going to come back to that because I'm going to talk about how to calculate wheel slips. And so I've got this other channel now, or other user profile, and I'll zoom out here. Actually, do we have that on? No. All right, so what wheel slip math channel is it's simply comparing, look at the left rear, one tire to the average, the speed of one tire to the average speed of the two tires at the opposite axle. Okay, so in this case, I'm taking the speed of the rear left tire and I'm dividing it by the average speed of the two front tires. Okay, and then I multiply it by 100 and I subtract 100, and uh, I'm not going to go into why all that happens, but the bottom line is it gets us a good scale so that you can really see the difference, that's happening with the tires that you don't necessarily see if you're just looking at wheel speeds. Okay.
And
So if
again,
you,
Robbie has linked these math channels. You can download these and import them into your test if you'd like, and I'll have them in the description box for the YouTube video. For those of you watching on YouTube, they'll be linked down in the description box. One thing, Ray and I learned something every time we do these webinars, and this was another one of those where Ray's way of calculating wheel slip was something a little bit different than ways I've seen it in the past and ways I've used it. He mentioned it a second ago. He takes the one he's trying to find the slip on, in this case, the front left, and he's comparing it against the rest of the tires on the car. I have always done some sort of an average, right? And Ray is the way Ray does it is really interesting to me. He always takes the average of the opposite axle. So in this case, it's the front. He takes the two rear tires and he averages those. And while that may seem like a small difference at the time, if you start doing these averages and you look at cars that are braking and you look at cars that are accelerating, if we always do the averages, they work good on one direction, braking or deceleration, and they work good accelerating. With him jumping back and forth and using the opposite, either the non-accelerating or the non-braking axle, he gets much more consistency. I think this is a pretty cool little trick, and thanks for sharing it, Ray. I think this will be helpful if everybody understands and starts to get the concept of what you're doing differently there. I think this is a pretty cool thing.
yeah, and to look at a front. So here's the left front match channel. We have the left front divided by the two rear wheels. Okay, the average
Of the two. Yeah.
Um,
Very cool.
so what does this tell you? Well, one thing you have to keep in mind when you're using these is that the lines will go opposite of each other, and I mean front to rear. So you can kind of see some lines. You can see a lockup here, the right front locked up, and you can see how big of that looks in the wheel slip math channel. But you can also see a little bit of movement here, and that you may not really notice. And over here, so you can see the ABS kicking in, and that tire trying to slow down more. Okay, but notice that in the rear, the lines are going up. Okay, so that doesn't mean anything to me. If the line's going down here, that actually tells me that tire was starting to lock up, and you can kind of see that as well. So I have braking and throttle up here, so I can always be sure of knowing what is the driver doing. Is he braking the car or is he accelerating the car? Because if he's accelerating, then I'm looking for wheel slip in the back. If he's braking, I'm looking more for locking in the front. Although you can, like we see here, you can also have locking in the rear. As you play around with it, you get more and more out of it, I think. The other thing I notice here is I look at the separation here. He's starting to go up the S's. Well, if you look at the speeds, there's a 2-mile-an-hour difference there. So right front is a little bit slower than the left front. Well, why is that? Well, I don't know for sure. I can't really see a whole lot in there in that speed trace. I can see it here. I'm expecting that, or suspecting that he used a little bit of curb there and got that right front in the air a little bit, So you can see how much it shows up in your wheel slip, whereas the rears are pretty flat. There's maybe
locked together pretty much. Yeah.
Maybe a little slip right there. All right, so now that we understand what wheel slip is, let's go back to where we have the yaw as well.
All right. Start to bring it all together at the accident scene.
Right. So again, I'm going to zoom in. All right. So now it's pretty clear that the reason why the yaw started was this wheel slip, So he started to have the rear tire spin up on him. The left started first and then the right followed. And why exactly that happened, I don't know. I just know that that's where the accident started for sure. Okay. Maybe he got into a little bit of oil there. We know that he was a little bit further to the right, and maybe there was something there that he didn't run across before. The other interesting thing is, again, it's much harder to see if you're not looking for it intentionally, is that the RPMs came up as well. So if I look to see at the RPM, so here he's at 67, 66, and there he's at 71.83. So what, 400 RPMs or so, right? So that's quite a lot when you're doing, 80 miles an hour.
Almost 90.
Yeah, almost 90 miles an hour there. Yeah, right. So how much time was that? Well, again, let's use our little measuring tool. Well, that was 0.65 seconds. Okay. So not a lot of time. And I told this to Roger. I actually watched a video of Dennis Macchio. And if you don't know Dennis, he ran Hurdle Roos School for a long time. And he's been a driver coach, has been around for forever, I think. Anyway, they were interviewing him, and he said something that was pretty interesting to me. He was talking about how quickly the human mind can process something. And what he's read is that if a mind is not expecting something, then it takes 0.7 seconds to react, to realize it, and then another 0.7 seconds to react to it. So that's 1.4 seconds if you're not anticipating. It can be cut down greatly if you're anticipating, what's going to happen. Okay. So in this case, I have to say that the driver just really wasn't anticipating that he was going to get wheel spin. And by the time he realized it was happening, it was way too late,
Always interesting how these things tie together. That we're going to talk about it in our next webinar slide coming up. Well, our next webinar is actually related to this a little bit. We're going to have engineering the driver is our next webinar, and we're going to have Matt Romanowski co-host with us, but we're going to have a guest, and that guest is Dr. David Ferguson, who's going to come in, world-renowned doctor, and works with drivers all around the world. And we may talk a little bit. He's going to talk more about fitness and some other things, but might be interesting to bring this topic up just a little bit and see what he thinks about that as well. Because if I'll take over the mouse just for a quick second, you can see that this wheel spin is happening. The separation is not huge at all yet, and the wheel spin happens, and then the wheel spin is starting to come down, and the separation still hasn't fully developed. and then it starts to really happen, which tells you that the wheel spin came before the huge rotation or the yaw of the car, as Ray was mentioning. I thought I'd just bring that up again real quickly.
Yeah. So, anytime I'm looking at data, I always kind of try to put myself in the driver's head. And I'm not 100% sure on this, but what I suspect was happening, going back to even before he got to the braking zone, was that he was really focused on carrying a lot of speed into the bus stop. So he's focused on corner entry, and he rushed it a little bit by creeping in. And at that point, he really should have realized that, hey, this is not where I should be, and start correcting for it way back there, But the thing is, you got to be careful if you're on the ragged edge with your car. You got to be careful about trying to make up your time at corner entry. I think most accidents happen when the driver is on the ragged edge with his car and he tries to make it up at corner entry instead of corner exit. Because in reality, the way you make up the most time is by getting to full throttle sooner and staying there. That's the important part. You have to stay there. So if you're so focused on corner entry that it screws up how soon you're able to get to full throttle, then you're going to lose time. So sometimes it's actually a little bit better to make sure you have just enough control at the entry so that you can get the full throttle sooner and stay there and get the best time through that corner.
Yeah, no doubt about that. And it is especially highlighted when the following straightaway, the longer the following straightaway is, right? So
Right.
yeah, absolutely. There's a couple things we'd want. Let's go over a couple of these questions real quickly while as you're kind of closing it up. Tice mentions this is talking about up at the entry to the uphill S's when you were talking about that front wheel speed. Can the difference in the front wheel speed be caused by the wheel diameter difference due to load? May be true, but on this particular track, and Ray, you were there, but that uphill S, there's not a huge load difference on the left side versus the right. You are basically full throttle and just going back and forth. So in this case, since it is wheel speed, that can happen because you're loading that tire and the other one is getting bigger. But in this case, I don't think so. Right?
No, I don't think so. And it's pretty common for people to clip the curbs in that area. So.
And with no room for error with those big blue guardrails going up through there, right? Matt mentions what is the Z Excel reading? In other words, the vertical accelerometer reading when the wheel starts to slip. What Matt is thinking there is, did the curb throw it up and release those tires to do that? We're watching it's both rear tires are doing it, so maybe not, but I'd have to look in there a little bit and find it. But
at this point, there is no.
At that point, no curb.
Yeah, I mean,
he's already landed from the curb before at that point, right? Yeah. Okay. And pro coach Peter Kraus, could you enable the other lap? I think if we did that here in this particular profile, we have so many things with double colors that we'd have to go to per lap color. I know we did show the throttle on both of them. You could see the throttle going. If as maybe as we're closing up, maybe Ray might want to do that.
Yeah, I mean, we can close out this lap and pull up the other one and see what the wheel slip is.
Okay, go ahead. Turn that one on. What he really wants to focus on is as it was happening, the throttle coming off as it's crashing. So you need to line the two of them up. Have the throttle position.
That's going to be very noisy.
Yeah, because of all the data traces. No big deal. Okay. Chassis bottoming out in the curbing is another comment that the curbs are big, but they're wide, but they're not super big for a sedan. An open wheel car, that may well be true. You may actually drag the bottom of the car if you hit it too hard there.
Right.
Yeah. Okay.
So this is about where it would be. And there's a little bit of slip and there's a little bit of spike here, but that's when he's on the curb. So there's really no spikes when he's in the middle of the bus stop.
Okay.
So
Yeah.
there wasn't any wheel slip there.
Okay. Perfect. Is there anything else in the data that you would like to show, or want to go back and take a look at the video one more time or anything as we kind of close this up?
Yeah, let's take a look at the video, the crash video,
Okay.
and maybe even the other one. And
Let's take a look at the good one first, and let's just take a. Oops. Oh, come on up. There, let me restart it. It started behind it. That was kind of odd. Here's the good lap. This is the non-crash lap again. Decent line, turns in about the right time. A lot of curb, not a ton. Comes out of it fairly well. And take one more. Let's take one more look at the crash video. I'll just let it play through. You can hear it.
Really
hear
slow.
it. Yeah, you can hear the RPM is behind probably for you guys, but
Yeah.
it's after the car is settled on the left-hand curb heading out that the RPM does rise. You can hear it.
Yeah, you can. Yeah.
Okay.
So that's, really the techniques that I showed here can be used, for anything, but it's important to sometimes look past just the standard data traces, because it's really hard to pick some of that stuff out, using things like corner radius, wheel slip, basically those math channels just amplify things, and it just helps you find out what's happening, So.
Exactly. The funny part is this particular data file, by the time we dug deeply through it, we found something that we think was probably pretty close to the actual answer, but spinning the tires coming off that second that second curb, it starts to lose it. He was a little behind, maybe not anticipating it as much as he maybe could have, but he probably would even have gotten away with it, except for these three or four other things. It's always a string of things that create these things. He did enter, got on the brakes later. He rolled through 4 or 5 miles per hour faster with a different line and got on the throttle earlier. And then the final result of that was spinning the rear tires and losing the rear end of the car and spinning it around. It's accident investigations, just like data. It's hardly ever black and white, right? It's you end up with this chain of things, and you start at the accident, you start to go backwards in the data, and you find out what started the process, right? Accident investigation stuff, and I'll give you the last kind of the closing word on the overall theories, but it's you always start at the accident scene and go backwards, because you end up finding 3 or 4 things sometimes that actually added up to create the problem.
Right. And the thing is, if you just looked at the video, it's just really easy to come to the conclusion, oh, he took too much curb coming out and that was it. Well, that wasn't it. That was a byproduct of what happened before. By the time you got to that curbing, it was already gone. So you have to be a little bit careful if you're just looking at video. I think video is extremely important. But if you're really trying to dig in, I think you really need the data.
Yeah, the video is a great place to start, and maybe even going back to it later is you see some things after looking at the data. So it's really a combination. We did all this in Ray Studio 2. Ray Studio 3, when the analysis is up and running beyond the beta, we didn't want to do this one in the beta. You'll have the video sitting there at exactly the same time, all totally synced up together, which will make this process even more visual and probably better. So,
yeah.
Okay. Let's bring up the PowerPoint. Let's jump out of that and kind of start to wind this down just a little bit. We have this one will be up within an hour or so. We have this will be video number 140 on our YouTube site. Tons of great videos out there. This one, of course, and we'll be doing one of these every Tuesday from at least now till the end of March is what all of you have probably got on your calendar. And we may do some on Thursdays, like we have in the past, some special ones. We'll see if you guys have any any thoughts on that, drop me an email. My email address will be here in just a moment. If you have some other ones that you would like to see, some topics you'd like us to discuss, boy, send them in to me. It feels like we need to do a little bit more than just every Tuesday, just with the number of topics that I have, but we're going to schedule them for sure every Tuesday, and maybe we'll throw in some Thursdays, and we'll make sure the word gets out. So go visit the YouTube site. That's where we store all these when we get done with them. The customer support, boy, our guys have been on the road like crazy, even this time of year. I know some of you have been racing quite a bit as well. Make sure you look for us or give us a call at our tech support line. Let us help you if there's any way that we can. The next one, I mentioned it a little bit earlier. The next webinar we're going to have, it's next Tuesday, January 12th, same time. Engineering the driver, the science of motorsport. And as I mentioned, Matt's going to be there to help. He's a much better co-host with this topic than I am. And Dr. David Ferguson is going to join us. He's from the Spartan Motorsports Performance Lab. I think it's University of Michigan. He's a professor there, but he's also a motorsports enthusiast, and he works with people, and a lot of people that you have heard of, and he'll be talking about some of that and some of the backgrounds and how he understands stress and when the driver is getting tired and how things are happening. We're going to talk deeply about that. I really suggest that if you enjoy that kind of topic at all, come join us on next Tuesday, January 12th, a week from today. That'll be a fun one. The contact information, Ray, again, thank you very much, Ray, to begin with. Contact information for Ray, there's a website there. There's his email address and his phone number, contact information. Again, Ray does a lot of things, not only just at the track working with teams, but he also does a lot of services where people send in their data. He creates some of these math channels and user profiles that he has talked so much about with us. And of course, accident investigation type stuff, taking a look at this accident data and trying to, analyze what went wrong. Of course, there's my information. I did see a couple of folks were asking about the Radius channel and some of the other ones. If you can't get it or don't want to get it out of the zip file that has been linked in the chat box, or will be linked in the description box below the math channels that Ray has provided us, email me directly, roger@aimsports.com. I can send those all out to you in an email where you can cut and paste them into your own math channel files if that's what you're after as well. No problem there. So make sure you get back with us on there. Again, Ray, I appreciate you being here. This was your fourth one, and I'm sure that we'll have you back if you would be so kind to do that with us. And but I appreciate you being here. Is there anything else you'd like to add as we kind of close this one up?
No, just thanks for having me. This was a fun one for me. I hope a lot of people got something out of it. Yeah, no, it's always fun to dig into data like this, and hopefully I'll come back.
Absolutely. I have learned as much from this one as I have from any of them. And between us chatting beforehand and a few things that you threw in during the webinar today that we didn't chat about. So I appreciate that. Thanks, everybody. I appreciate it. Thanks for coming. Again, look forward to seeing you all a week from today on our next one with Dr. Ferguson. Thanks, everybody, for coming. Talk to you soon.
Bye, everyone.